Okay, now we're going to look at the process of finding derivatives of inverse functions. So let's look at a few of the parent functions. Here's a linear equation, right? So when you find the inverse, remember you swap the x's and y's. Well, the linear equation, its inverse is itself, all right? But what happens when we find the inverse of a quadratic? You can't really take a square root of a negative number. So when you take the inverse of a quadratic, you have to specify for all the x's that are greater than or equal to 0, and then the inverse just becomes the square root graph. And then that makes sense because then that fits the graphic. Graphically, you can see that they're inverse, but only for a limited domain. For this one, it's for the entire domain, all right? And then for the cubic, when you take the inverse, you get the cube root function. These two are inverses of each other, and for both of those, it's the entire domain. Okay, but algebraically, so if you have an original function, but you have to find the inverse and then take the derivative of that inverse, this is kind of the formula for that. Remember, an inverse, multiplicative inverse, is 1 over a value. So if you have x, the multiplicative inverse is 1 over x, right? So we have 1 over, but then we're finding the derivative, so it's the derivative of the inverse. So the inverse is 1 over, and so that ends up being the inverse, but you take the derivative of that inverse. So this is the information that we need. We need the original function, we need the derivative of that original, and we need the inverse of that original. So let's go ahead and do a couple of easy ones, and then we'll do another video. We'll do a couple more difficult ones. So we have this linear function right here. The derivative of that linear function, well, the derivative of 2x is just 2. Well, that's pretty easy. When we find the inverse, remember the steps, we swap the x's and y's. So if we start off with y is equal to 2x plus 2, we swap x is equal to 2y plus 2, then we use inverse operations. So x subtract 2, that leaves us with 2y, and then divide 2. So the inverse is now x subtract 2 over 2. All right, so now we can plug it into this. So the derivative of the inverse is equal to 1 over the derivative. The derivative does not have an x. So there's no need for the parentheses. It's just 1/2, and that should make sense because remember the derivative slope of the tangent line, remember, is the function that produces the slope of the tangent line. Well, if the original slope is 2, then the inverse is 1/2. All right, let's try another one where it's not just going to be a fraction. So we have 4x squared plus 1. Ooh, this is one of the tricky ones because we have to limit the domain, right? So let me see if I can, let me move that over here just to give myself some more room. All right, so the derivative of this function, well, 4x squared, the derivative of 4x squared is 8x. The derivative of 1 is 0, so this is the derivative. For the inverse, I'm going to change this to y. We're going to swap out the x's and y's. So we have x is equal to 4y squared plus 1 We're going to subtract 1 on both sides. And that gives us 4y squared. We're going to divide both sides by 4. That gives us y squared. Now we're going to take the square root of both sides. So the inverse function is the square root of x subtract 1 all over 4. All right, so I'm going to move this to right over here. And now, let me get this out of the way. Now we can plug it into that formula. So here's our derivative. So we can say the derivative is 1 over our f prime is 8x. And where the x is, you would put the inverse. So the inverse is the square root of x subtract 1 over 4. And then you can simplify this. Well, what's 8 divided 4? It's 2. So we end up with 1 over 2 square root. I almost made a mistake. What's the square root of 4? The square root of 4 is 2. What's 8 divided 2? 4. So, just like that. All right, that's it for this one. Be careful about making those types of silly errors. All right, the derivatives of the inverse, we're going to do a couple more complex ones next video.